Today, we are going to talk about the possible cases of intersection between three planes. So before we start, how many different ways can you think of when three planes intersect? Let's find out together. In R3, there are three axes, which are the x-axis, y-axis, and z-axis. There are a total of three cases to this question. First up is the case where all three planes are parallel to each other, which also means that their normals n are parallel to each other. But there can be three different types of scenarios to this case. The first type is where all three planes are parallel but distinct. Because they are distinct, which means that there is an all-inconsistent system, therefore there are no solution to it. Now before I go any further, what does it mean for solution to be consistent or inconsistent system? If a system has at least one solution, it is said to be consistent, while on the other hand, if a system has no solution, it is said to be inconsistent. Another different scenario is where all three planes are parallel and coincident. This also means that this is a consistent system and have infinite solutions because all the x marks on its plane is a solution. Last scenario for this section is where two planes are coincident, but one of the planes is distinct. This will result in an inconsistent system because one of the planes do not share any points with the other two planes, which also means that this system has no solution. Moving on to the second case is where we have two planes that are parallel and one plane is not. Therefore, the relationship between the normal is n1 parallel to n2, but not 2 and 3. In this case, there can be two different types of scenario. The first type of scenario is the two parallel planes that are coincident, whereas the second scenario is where two planes are parallel and distinct to each other. In the first scenario, where the two parallel planes are coincident and a non-parallel plane, the solution is a consistent system with infinitely many solutions, as there is a specific line where the planes intersect with each other. We can also interpret the scenario into an easier way. Since the two parallel lines are coincident, we can join them together to become as one plane. This way, you will only have to deal with two planes. The next scenario is where we have two parallel planes and distinct planes with a non-parallel plane. The solution to this is an inconsistent system, which means that this system doesn't have any solution. Last but not least, it's the case where all three planes are not parallel to each other. This also means that all the normal are not parallel to each other too. For this case, it's a little different compared to the other two cases, because for this case, you have to perform volume tests on the three normals before solving the system. Why do we have to do the volume test? Volume test is to let you have an idea of what the system will be like. When you are performing the volume test, perform the cross product first, followed by the dot product. Now back to the system. If the result of the volume test is not zero, then the three planes must intersect at an exact point. This also means that this system is a consistent system and have only one solution. Meanwhile, you will have two possible outcomes if the volume is equal to 0. The first outcome is when the result is a contradiction answer, and the second outcome is when the result is a true statement. A contradiction answer is when the left side of the equation does not equal to the right side. If the answer for volume test is a contradiction, then the planes will intersect pairwise, which is inconsistent system and have zero solution. A true statement is when the left and the right side of the equation are exactly the same. If you face a problem where the result is a true statement, then the planes will intersect at a line resulting in a consistent system with infinitely many numbers of solutions. After all this taking, let's put everything in a place in the picture of us to have a better understanding of what is happening. In the middle, we have intersection of three planes, which is basically what we are learning now, which is then separated into three different major cases. The first case, which is when all the normals are parallel. For this case, it can be further separated into 3 more minor scenarios. The second case is when 2 out of 3 normals are parallel, which can be separated into 2 scenarios. Lastly is when none of the normals are parallel, which can be separated into 2 more sections, which is when the volume equals to 0 and when it does not equals to 0. Let's do an example. Given 3 scalar equation of planes, describe the system. First, we have to write the normals down, then we compare them. By comparing them, we found that plane 1 and plane 3 are parallel, but not with plane 2. Since plane 1 and plane 3 are parallel, we compare their d values to see whether they are distinct or coincident. Apparently they are not equal, therefore we can say that this system is an inconsistent system and have no solution. That's all we have for you today. Thanks for watching.